Students, this is the help video for the Unit 3 key questions. The absolute most important step of each of these problems is the fact that you should try them yourself before you access the help video. So for each of these, I recommend you get your phone and you set a timer for 5 minutes. And you do everything you can in 5 minutes all by yourself. So for this problem, set a timer for 5 minutes, do what you can by yourself, pause the video. All right, welcome back. Let's see how you did so far. We're going to take it one step at a time. Says right here that RST is an isosceles triangle with S as the vertex. That means S is the hinge between the equal sides. And it does not matter which one's T and which one's R. And then RTW is adjacent to RTS. Adjacent means back to back. You look very carefully. R is shared and T is shared. That means RT is the shared side between two other triangles. So RTW and RST are adjacent where SRW is a right angle. Says RTW is isosceles with T as the vertex. So T is the vertex going this way. That means these two sides are equal, which will force these two angles to be equal. And in the triangle above, these two sides are equal. Therefore, these two angles, two equal sides, two equal angles. The measure of RST, so you trace it, RST, that's this angle, is 3 times the measure of RTS, RTS. So that's a 3x and an x relationship. Your goal is to find all possible angles. One little hint, 2 equal sides, 2 equal angles. So if this is x, that's x. And you trace and you ask yourself, what is true? What is true? You must finish this yourself. Show all your computations in the margin. Okay, for this problem, once again, put your finger on the diagram, read this entire page yourself. Set your timer for 5 minutes. Do everything you can all by yourself in 5 minutes. Ready? Go. Pause the video. Do your own work. Okay, students, this is a learning experience. So if you have something drawn here in pencil, that's fabulous. If you're copying this from a blank page, that's not a learning experience. That's copying. This is meant to be a redirection, put in the right place. It is not meant for you to start with the blank page because on the test day, on the oral exam, you have to be able to translate these sentences yourself. And it's easier for you to learn if you try and then redirect versus you don't try and you just smooch off a blank page. So hopefully you've drawn something. Let's see how accurately you've drawn this. Okay, so step number one, it says to HIJ is an obtuse isosceles triangle with H as the vertex. That means H is here. Says it's obtuse, so whatever this angle is, it's obtuse, which means bigger than 90. Does not matter which way is I or which way is J. P is the midpoint of HI. Q is the midpoint of IJ. R is the midpoint of JH. And you're going to draw in the mid segments. PR, PQ, and QR. Those are all mid segments. You're going to draw and extend JH, making an exterior angle. So JH, an exterior angle. Clockwise, extend HI, sweep the exterior angle. Clockwise. And trace IJ and extend clockwise. You're only given 3 pieces of information, I to J. It's 36. Q to J. No, that's HJ, excuse me. HJ is 36. So from here to here is 36. QJ is 20. And the measure of JHI, JHI right here is 104. Find the measure of all possible angles and segment lengths. So there's 2 things you want to keep in mind here. Actually, well, 3, excuse me. 3. 1 is each of these mid segments are both parallel to the side it's facing and half the length. Parallel and half. So these segments right here, 36, and this mid segment it's facing has 2 qualities. This is a 2 bunny hop, and this is a 1 bunny hop. Next, you got to watch out for, because they are parallel, you need to watch out for, trace it, armpits of the Z. That means these angles here and here are going to be the same. That's 1 armpit of the Z. There's more than 1 here. Here's another one, armpits of the Z. So that makes this congruent to this. And when you have parallel lines, not only do you need to watch out for armpits of the Z, we also need to watch out for corresponding angles when lines are parallel. Corresponding angles are going to be congruent. I'll give you an example of those. That means right here, this angle and this angle are also going to be equal. And then, of course, watch out for 2 equal sides, 2 equal angles. So you would know that this angle here and this angle here are going to be the same because you were told right in the beginning that this triangle is isosceles, two equal sides, two equal angles. Find all possible segment lengths and angles. Okay, for this problem, once again, set your timer for 5 minutes. Do everything you can on your own before accessing the rest of the video. It's easier to correct than it is. It's more significant to correct your work than it is to copy your work. Ready? 5 minutes and go. Pause the video. All right, students, welcome back. Hopefully your diagram's already marked. Let's see what we have here. You're told that B, C, and EF are congruent. So this length, I'm going to use a bracket here. Congruent. You're also told that AC is parallel to DF, so I'm going to stretch it out and do the little arrow feathers. Okay, we are done with our given. What are we trying to prove? We're trying to prove the angle BFC. BFC, that's this angle, and ECF, this angle, that they are congruent. We're putting question marks there. Now, we cannot use armpits of the Z because armpits of the Z here would only work if I told you these were parallel. I don't tell you that. So instead, your ambition is to explain how this triangle, BFC, the triangle, is congruent to the other triangle. And then if you can get the whole triangle equal, then you can say the parts are equal. So we've already have our given. And so far, our first given gives us a pair of sides. Implied by the parallel lines is going to get us angles 1 and 2 because of alternate interior angles, armpits of the Z. Should be tracing that, armpit of the Z. And that'll get us a pair of angles. Then down the middle, you have a reflexive side. So we know our triangles are going to be congruent by side angles. Side, that's our triangles congruent. If our triangles are congruent, if our whole's equal, then our parts are equal. If our whole is equal, then our parts are equal. So there's a couple ways you can write this up. You have to do it yourself. One way would be to use the web. And for the web, you would talk about those sides first and tell us why they're congruent. Then you would talk about the parallel lines first. Tell us why that's true. Parallel lines would give you the congruent angles. You have to name them, and you have to be able to explain why that is true. So there would be your angles. You would have to talk about the reflexive side down the middle. All 3 pieces of information gives you triangles congruent, and you have to name them. and explain why that's true. And then you must have parts congruent, the angles, and you must explain why. So that's what a web might look like. Or you can do a 2-column with the I know that and what's true and why is it true, each and every one. And it would be side angle side bullet, which triangles are congruent, and then the parts congruent. So every sentence is a what and a why. Okay, for this problem, once again, set your timer for 5 minutes. Try to do this to the best of your ability without using the help video. Then access the help video. 5 minutes, ready, and go. Pause the video. All right, students, welcome back. Let's see what we have here. Says right here that triangle BAC is isosceles with A as a vertex. That means I have 2 equal sides. We're also told that angle BDC, that's this angle up here, is congruent to angle CEB, that's this angle up here. It's a little hard to see those angles. We're trying to prove somehow that the side DC and the side EB are congruent. Now, there's no direct way to do that. Isosceles doesn't cover that. But if you do whole equal, you can do parts equal. Whole equal, parts equal. You were told right here that you should trace and pull apart the triangle DBC. This triangle right here. DBC. And triangle ECB. ECB. We're going to trace and pull those triangles apart. And our goal is if we can say the entire triangles are congruent somehow, then we can say that this length and this length are congruent. I'm putting question marks there because we don't know for sure unless we can prove the triangles are equal. So let's go over the information that we have. We just marked our given, implied and freebies. If this side and this side is congruent, then this angle and this angle is congruent, which is angle B and C. That's indirectly congruent because of the isosceles. That would give us a pair of angles. You were also given that these angles, right at D and E were congruent. It was given. There's another pair of angles. So far, we have 2 pairs of angles. Now watch very carefully. BC, BC, BC. BC, it doesn't look like an apartment wall, but it is exactly shared by the 2 triangles. Shared, it's overlapping. We still call that reflexive. There's a side. So these triangles are going to be congruent by angle, angle, side. So if you were to do a web proof, you would have your first pair of angles, which were given. Your second pair of angles were not given, but they are indirectly implied because you were given an isosceles triangle. You need to explain this. You can't just write this skeleton that I'm doing. You must explain it each and every step. So the isosceles would give you a pair of congruent angles. You must name them and give a reason why. You must name these and give a reason why. Then you had a reflexive side, stands alone. That's the same side, congruent to the same side. Reflexive. All three pieces of information would give you triangles congruent. You must explain why and be specific. And if the triangles are congruent, then the parts are congruent. That's the general web proof. If you were to do a sentence proof, you would explain angle, angle side, what's true, and why is it true, each and every sentence. You would explain how the triangles are equal, and you must be specific, and then how the parts are equal, be specific. What's true? Why is it true? Okay, for this problem, I suggest you do everything you can by yourself. Most of you did most of this in class. But if you didn't, you're going to work on it now, 5 minutes, all by yourself. 5 minutes, try to do what you can on your own. Pause the video. Okay, students, most of your computations should be done right now. We have A, and we have B, and we have C. And there's three things you're trying to prove here. You're trying to prove, one, it's isosceles, which means two equal sides. Two, you're trying to prove you have a median, which is a segment that connects vertex to a midpoint. Vertex to a midpoint. That would constitute a median. Three, you're trying to prove that that same segment is also an altitude, which means you would have to prove that they are perpendicular or make a right angle. That would prove an altitude. So to show length, you would use the distance equation. So you would find the distance of AB and BC. If you've done this correctly, those two distances should be of equal measure. So you have to do your own math there. Then, to show you have a median connects vertex to midpoint. You have to find the midpoint of AC where you add the x's, divide by 2, add the y's, divide by 2. You're going to get an ordered pair. If you've done this correctly, you plot that ordered pair. It should look like the exact middle of AC. And that would prove that you would have a median by connecting vertex to a midpoint. Finally, you would find the slope of AC, and you would find the slope of B, and that midpoint's going to be Q. And remember, slope is y minus y over x minus x, rise over run. And you want to prove that there's a right angle there. Well, when things meet at a right angle, the slopes are opposite reciprocals of each other. So they should multiply to -1. When you do your write-up, each sentence, you have to have one sentence related to y is isosceles, one sentence y is the segment, a median. How do you find a median? What is a median? And then one sentence, how do you know you have an altitude? Why is the median also an altitude? And each of these sentences, you must cite your math, explain what does the math mean, and then make sure you actually tackle the punchline of what you're trying to prove. Math, meaning, punchline. You must do the constructions here. There is a video for this. Follow the video online for this one. For this problem, once again, set a timer for 5 minutes. Do the best that you can all by yourself for 5 minutes. Go. Pause the video. You have points J here. Welcome back. We have 4 and -4, +3. That's J. K is at 0, +1. L is at 0, -3. And M is at -4, -1. We're trying to prove the triangle JKL is congruent to the triangle LMJ. Remember, the minute you're trying to get congruent triangles, you're shooting for side, 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 angle, side, angle, side, angle, or angle, angle, side. This one, it says, I only want you using the distance equation. So you find the distance of JK, distance of LM. If you've done this correctly, those two distances are going to be of equal measure. That would give you a side. Then you find the distance of JM, LK. If you've done this correctly, that will also give you a side. Then you have a freebie down the middle. You know that JL is congruent to JL. That's called reflexive. So you know that the shortcut to show these triangles equal is going to be side, side, side. And then your punchline will be the fact that the triangles, you must name them, are congruent by the shortcut, side, side, side. So each of these steps, you must say what is congruent and why is it congruent. And remember, you must cite the math and explain what it means. Then you hit your punchline. What are you trying to show? Math, meaning, punchline. See question number 8. Here, it's the same points that we started with for this one. J is at -4, +3. And once again, we're trying to prove these same two triangles are congruent, but this time we are only allowed to use slope. So you're going to find the slope of JK. Here, again, that's y minus y over x minus x. Then LM, y minus y over x minus x. If you've done this correctly, those slopes are going to be the same, making these lines parallel. And then you're going to find the slope of JM and KL. And again, they should be equal, which implies they're parallel. And then remember, parallel does not give you congruency. It just gives you parallel. So you can add numbers for the angles, which we're going to do just to make it easy to work with. I'm going to call that 1 and 2, 3 and 4. Because the blue lines are parallel, in this case, angles 1 and 2 would be congruent. It's a pair of angles. Because the green is parallel, 3 and 4 are congruent. That's going to give me another pair of angles. And then a side down the middle because of the reflexive property. So in this case, the triangle is going to be congruent by angle, side, angle. Angle, side, angle. Your punchline will be the triangles are congruent. And again, you must cite the math. What does the math mean? Then hit the punchline. What is congruent? Math, meaning, punchline. Remember, parallel lines, slope equals slope. This is a problem we did in class. Hopefully you have attempted to draw it yourself. One step at a time here. FGH and FQH are adjacent triangles. Adjacent meaning back to back. And notice what letters are repeated. F is repeated. H is repeated. So that means FH is the shared side. We are told that we have an obtuse triangle FGH where G is obtuse. Now we know a little bit what this looks like. G is going to be obtuse. Angle FGFH, so that's G FH and HFQ, which is the other triangle. So GFH, that's this angle. HFQ, that's that angle. Here's your other triangle, FQH. Are complementary. Complementary means adds up to 90 degrees. So that means these two angles add up to 90 degrees. FGH, FQH are adjacent. FQH is right here, is a right triangle where Q is the right angle. HFQ is 5 times the measure of FHQ. Here's FHQ goes this way. FH bisects QHG. Here's Q. Here's H, here's G. Bisect means to be cut in half. Find the measure of all possible angles. Well, you start with where you can start, and inside of this triangle, we have a 5x, we have an x, we have a 90, and we know triangles always add up to 180. All of that vocabulary you need to be familiar with. There was a lot of vocabulary here. Vocabulary like the word obtuse. Isosceles. Right. Complementary. Bisect. Adjacent. You need to be familiar with all of that vocabulary. Okay, this problem, you're going to have a shot at extra credit during class time. But the scenario is this. People were drawing accurate maps for centuries prior to the invention of any electronic or digital equipment. One might wonder, how did they measure terrain across which could not be directly measured safely? You and your quad mates are part of the 1905 surveyor team in charge of creating a 2-scale map of the Amazon River. Besides pencil and paper, you have these tools: a protractor, a tape measure, a long one, telescope, and what's called an angled ruler and a tripod. You must use concepts about congruent triangles. That would be side, 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 angle, side, angle, side, angle, or angle, angle, side, to describe a way that you could indirectly measure the distance across the Amazon River only using the tools above. The diagram on the right shows that you're on the right side of the riverbank, point R. There's a landmark of a tree, T. You may only take measurements that you can use reached from the riverbank. No, you may not toss the tape measure across. That is impossible. It's dangerous. It's too far. It's dangerous currents. So you cannot directly measure that. You're going to use the diagram on the back, and you're going to write on an explanation how you can indirectly find this measure. Indirectly find it. It says it's worth extra credit points. You can add extra letters. So things you can measure from the riverbank only. from the riverbank, you could put your tripod here using your telescope and your protractor. You could measure without getting your feet wet. You could measure that angle. Can measure that. You had an imaginary triangle here, you would be able to measure that. So you'd be able to take those two angle measurements, as well as you could measure that distance right down the middle. Ask yourself, could I create a triangle on land that is exactly the same as the triangle over water? What else could you measure? Well, I could easily measure the midpoint here on a tape measure. Again, you're just along the side of the riverbank, so you're not getting your feet wet. And have an imaginary triangle right here to the midpoint. Again, you can measure this angle here with that tripod. You could measure that angle there. And you could recreate that angle on land. And you can make sure that these two segments were congruent. By recreating a triangle on land, you could indirectly get that measurement. There's a couple ways to do that. You need to write up a description and write an appropriate diagram that goes with it.